Good afternoon, and thank you for joining us for the 66th webinar in the Offshore Wind Series, Learning from the Experts. I'm Peter Lyon with NYSERDA's Offshore Wind team, and it's my pleasure to be joined by today's experts, Annika Mathiasson and Scheu. Before I introduce our speakers, a few reminders for participants and some background on this webinar series. Next slide, please. Firstly, if you're experiencing any technical issues, please contact Adam Hawk at the email address on the bottom of this slide. The webinar is being recorded, and the recordings and presentation slides for all webinars in the Learning from the Experts series are available on NYSERDA's website at the address on this slide. All participants have been muted. We'll have time for Q&A following the presentation, so please use the Slido feature to submit your questions. Next slide, please. New York State is working to advance the responsible and cost-effective development of offshore wind as part of a diverse energy supply. Offshore wind is a critical component in achieving the state's energy reliability and decarbonization goals. While offshore wind has been providing clean energy to other parts of the world for several decades, this industry is brand new to New Yorkers. To provide interested stakeholders and members of the public with accessible, impartial information and opportunities for engagement on specific topics of interest, NYSERDA is hosting this educational webinar series called Learning from the Experts to connect the public with independent experts in key topics in offshore wind. We endeavored to select Learning from the Expert speakers based on their expertise, not necessarily for an alignment of opinions with NYSERDA or the state of New York. Please note that the views and opinions expressed in this presentation are those of the presenters. Next slide, please. It's now my pleasure to introduce Annika and Matti. Annika is a lead consultant and deputy country director for the Americas at Peak Wind, based in Boston. She specializes in offshore wind operations preparation, operations and maintenance strategy, and offshore wind logistics. Annika has worked for more than 12 years across the offshore wind project lifecycle in Europe and North America, supporting developers and owners in preparing projects for safe, efficient, and long-term operations. Matti is a director at Peak Wind, based in Germany. He specializes in offshore wind operations and maintenance strategy, asset management, and O&M commercial and operating model design. Matti has more than 14 years of experience across the offshore wind project lifecycle, working with major developers and investors on optimizing O&M strategies, operating models, and lifecycle costs. I'll now hand things over to our speakers.
Thank you very much, Peter. And then we can move on to the next slide to quickly look at the agenda for today. So this presentation is gonna be held by both Annika and myself. And I would like to start out with a quick introduction of Peak Wind so that you get a better understanding of who is speaking to you. Let's move on and have a quick look at our world map here. So yeah, just a quick word on who we are. Peak Wind is a globally active company within the renewables. We have a focus on wind and specifically offshore wind. And then if you're looking at the map, you'll see that we're active pretty much in every offshore wind market globally today, from APAC, Taiwan, Korea, Australia, over to Europe, which is our home market with offices in Denmark, Germany, the UK, and Spain. And then into North America, where we're on ground in Boston, in Austin, and also in Canada. So yeah, wherever your project is sitting, we are ready to engage with you there. One very important thing to mention here, and which is worth mentioning to understand Peak Wind a little bit better, is that Peak Wind is born in the area of operations and maintenance. We started out advising projects and clients on how to set up technically and commercially sound operational strategies, all the contracts, the budgets, the concepts you need to actually run a performing offshore wind farm safely and efficiently. But probably the most important point on this slide is that we, as Peakwind, act in two roles. So we are both an advisor to our clients on those topics, and we're also an independent operator ourselves. So we are responsible during operation. We are sitting there in these projects in the middle between owners and investors on the one side, and then the supply chain and contractors on the other side. So to give a concrete example, which I've also referenced later, we have, for instance, a 900 megawatt wind farm operational in Taiwan under full management, and we are running that end to end, actually growing to 1.5 gigawatts with an extension which is currently under construction. And end to end in this case mean that we own the entire technical management, the performance management, watching out how it produces day to day. We're managing all the key contracts, and we also run a 24/7 control room with senior authorized personnel. So that's really important for me to mention that we are active both on the advisory side and also on the asset management side. All in all, today we are around 200 people around the globe, and of course, we are advising on many, many more projects than we're operating ourselves. So plenty of our clients are preferring to operate in-house or use other parties, and we're equally happy to support them that way. But when an owner wants us to take responsibility, then we're happy to do this. A quick overview about our core services are on the next slide. So yeah, just a quick tour of what we do. We call ourselves a one-stop O&M shop. So we're not a one-stop shop for everything, but for O&M, we can deliver everything needed to build, to ramp up, and to operate an offshore wind farm. So yeah, our asset management practice, where our 2.6 gigawatts of spinning wind turbines sits, is to the left here. Then we have our generation consulting team, and then we have technology and intelligence, where our engineering team is sitting, and tools like Sea Impact, which is an AIS-based vessel tracking software, and KPI intelligence company sitting there in the technology and intelligence area. I do think the rest is probably less relevant for this webinar here, but happy to go deeper on any of these. We can move on to the next slide. And this is also just for reference. I think these are some key achievements at a glance. And the only one I really want to highlight is that we are, as Peakwind, actually the largest independent operator of offshore wind globally at the moment. That's a pretty novel concept for the industry, and it's how some of our clients are able to leverage their involvement in offshore wind without building the full operating capabilities themselves. Yeah, and the rest you can see on the slides. And in the interest of time, I will hand over to Annika. Thank you.
Thanks, Matti. Hi, everyone. So we'll start with a safety moment on the next slide. Thank you. So offshore wind operations depends on safe, coordinated decision-making, and that really begins with planning. So safe operations start long before any work begins offshore. It starts with making sure everything is thoroughly prepared. This is vessels are ready, the weather windows are understood, and also access methods are clearly defined. Planning early allows us to execute work safely and efficiently. It also means having a clear understanding of activities, roles, and conditions before anyone steps onto a vessel or a turbine. The second is communication. Offshore projects rely on multiple teams working across locations, onshore and offshore, often in complex and changing conditions. Clear and regular communication is essential to keep everyone aligned. Information must be transparent and timely at all levels. And just as importantly, we need to confirm that messages are understood before work begins and not just sent. And the third is care. Care is about culture. It goes beyond procedures and checklists. It means looking out for each other, our teams, and our stakeholders. It also means speaking up early if something does not feel right. and it means empowering everyone, regardless of role, to stop work if needed. So safety is not a single action or responsibility. It is a result of consistent planning, clear communication, and a culture of care embedded in everything we do. If we move to the next slide, before going through how O&M works in practice, on the next slide, I'll briefly align on terminology. So offshore wind uses a wide range of acronyms, and this is like technical terms like W2G, that's wind turbine generator, to contractual ones like SMA, service and maintenance agreement. And we'll also be using logistical terms like SOV, service operation vessel. And if you don't work in this space daily, it can feel like a different language. So I've included this as a reference, and you'll also find a link above to Windopedia. This is a useful resource that explains common terms and concepts that I've also found quite useful. So I'd encourage you to use it throughout the presentation. If you come across a term that's unfamiliar, you can look it up here. And then please also let me know if there's a term you see that isn't included, and I'm happy to give that feedback to PeakWind. But take a look, it's a neat resource. And now if we move on to the next slide, I'll step into what O&M looks like in practice. So O&M is the center of wind farm operations. And it's important to recognize that O&M is always project specific. So it's shaped by site conditions, the contracting strategy, and the operator model. So there's no single solution that works for every project. But to simplify things, we also think about the scope in two main areas. So first is balance of plant, or BOP, and this typically includes all the non-turbine equipment needed for the wind farm to operate. These are elements such as substations, cabling, foundations, substructures, and the associated SCADA systems. And the second is wind turbine generator, WTG scope. And this is often managed by the OEMs. And this generally covers everything above the transition piece. So this includes like the tower, the nacelle, rotor, blades, and the turbine safety systems. Now, the overall objective of O&M, operation maintenance, is simple in principle. And this is to maximize performance, minimize cost, and always maintain safe operations. But in practice, delivering on the objective requires a highly coordinated system. This is linking vessels, ports, supply chains, and digital monitoring. So even a relatively small component failure offshore can trigger a complex change of activities. It may require sourcing spare parts from a warehouse, scheduling the right vessel, mobilizing technicians, and aligning all of that with suitable weather conditions. So what might seem like a simple issue is, in reality, a coordinated operational response. On the next slide, an O&M facility is essentially the operational hub of a wind farm. It's a base from which all O&M activities are coordinated, bringing together office functions, control room operations, and logistics in one place. It's also important to note that the setup is highly project specific, particularly in offshore wind, where the port and the operation facility are not always located at the same location. A key part of the setup is the warehouse. This is where spare parts, tools, and equipment are stored and sent out to support both planned and unplanned maintenance. Together, the facility and the warehouse enable fast and efficient responses offshore, ensuring that teams have the right resources to keep the wind farm operating. On the next slide, we provided some visual examples of rooms inside a typical O&M facility. So these include a reception area, meeting rooms, a control room, as well as office spaces, changing facilities, and canteen areas. Starting with reception, this is typically the entry point, supporting site access control and helping coordinate visitors and personnel arriving. The meeting rooms is where daily coordination happens. This is such as like toolbox talks, planning sessions, and alignment between the crews. And then the office spaces support the wider team, who's covering planning, logistics, engineering, and commercial functions that keep the operations moving running smoothly. Changing rooms are also an important practical element, especially for offshore technicians. This provides space to prepare, change into PPE, and transition safely between onshore and offshore environments. And then the control room, that's really the operational heart of the facility. This is where the wind farm is monitored in real time and where key operational decisions are made based on performance data and alerts. And finally, the canteen area is a place to eat and reset. And this is important to maintain a safe and productive workforce. So when we move to the next slide, you can see that the warehouse plays a critical role in supporting day-to-day operations. So this includes the warehouse coordinator's office, and this is where inventory, logistics, and dispatch activities are managed and tracked. You'll also typically find a workshop area, which allows for minor repairs, preparation of tools, and pre-assembly of components before they are sent offshore. Access points to the warehouse are designed to support efficient movement of goods. And then there's also designated hazardous materials rooms where specific components and substances are stored safely in line with strict handling and safety requirements. And then finally, there's the main storage areas, and this holds spare parts, tools, and critical equipment. At the port on the next slide. Perfect. You'll typically see a quayside and in many cases a pontoon working alongside it. The quayside is a fixed permanent structure along the harbor. It forms part of the core port infrastructure and is used for vessel mooring, loading and unloading, and handling heavy equipment. This is typically where larger vessels, such as an SOV, are supported. In contrast, a pontoon is a floating platform connected to the quayside. It's designed to move with the tide, allowing for safe access to vessels, and is usually used for personnel transfers and lighter equipment, particularly for smaller vessels like CTVs. And these setups, they're awfully in close coordination with port authorities, and they must be aligned with local infrastructure and regulatory requirements. On the next slide, I'll briefly walk us through 3 ways of transporting technicians offshore. Now, it's important to note that there's no single logistical solution that can address all project-specific requirements of an offshore wind farm. Instead, many projects rely on a combination of solutions to create a more optimal setup. So the 3 main options are SOVs, CTVs, and helicopters. And each of these solutions have their distinct advantages. So the SOVs, they allow technicians to stay offshore for extended periods of time, and this significantly reduces the transit time. These typically accommodate around 40 to 60 technicians, and they operate at speeds around 10 to 12 knots, and they can work in sea states of approximately 2.5 to 3 meters. And the access is through a gangway used for transfer. And then also a daughter craft may also be used to supplement the SOV, and this increases flexibility at the site. And then CTVs, on the other hand, they provide flexible day-to-day transport. And so these vessels, they can normally carry around 10 to 20 technicians and can operate at higher speeds, so around 15 to 20 knots. This, of course, depends on speed restrictions. And they're more weather sensitive. So they're typically limited to wave heights around 1.5 to 1.75 meters. Large equipment can be transferred on the foredeck of the CTV, and access for these is through the boat landing. And then helicopters, these offer speed and reliability, particularly for urgent interventions. So they can be used for quick access if that's critical, but they do depend on visibility conditions. So typically requiring around 80 to 90% daytime visibility. And then helicopters hoist the technicians either to the turbine or helideck on the offshore substation. So the choice between these options depend on several factors. This includes distance to site, weather conditions, the wind farm size, and also like the overall cost structure of the project. And if you're interested in learning more about vessels, Pequin wrote an article that addresses some key technical risks that the asset owner should consider when sourcing an SOV. So we've linked that article below on the slide here. And then moving to the next slide, I'd like to quickly walk through some of the specialized logistics that we also use in the operational phase. So starting with tugboats, these are small but powerful vessels that play an important support role. They're used to assist in maneuvering larger vessels and structures, tow maintenance equipment, and also help position vessels during operations. And then they also provide support if needed in emergency response or surveillance. And then for subsea, we have ROVs. These are unmanned underwater systems, and these are equipped with cameras, lights, and tools, and they're controlled by a surface level vessel. Then ROVs are used to inspect and maintain the subsea infrastructure. This is such as like cables, foundations, other structures. And they also collect environmental data for ongoing monitoring. And then finally, we have cable laying vessels. These are specialized vessels used to lay, to repair, and to maintain the subsea cables that connect the wind farm to the onshore grid. And these are equipped with dynamic position monitoring systems that allow them to like hold their position even in challenging conditions, and also carry out tasks such as seabed surveys, trenching, and installing subsea equipment. And then moving on to the next slide. Mindful of time, I'll just briefly highlight a few of these visuals. Here you can see a 60-pack SOV, and the helicopter photo, that is actually of me from a hoisting training I did a few years back. Just having these opportunities to be hands-on in operations, that's really helped shape my understanding, particularly when developing strategies early on that then ultimately impact the operational phase. And then when we move on to the next slide for the next session, I'll go through how different ways offshore wind projects are structured operationally. So one of the key takeaways here is that there's no single model that fits every offshore wind project. So each operations model is shaped by factors such as the project strategy, it can be the capability of the stakeholders, the contractual setup, and then the overall risk allocation. In practice, this means that different projects will structure their operations differently. So whether it's having a fully integrated operator or a more independent management setup or a hybrid approach that combines multiple roles. On the slide, we've highlighted a project structure where you can see corporate and operation services are outsourced. So the operator manages the service agreements and the asset management and corporate services. In the middle, we have a fully active project structure where corporate and operation services are driven out of the project. And then lastly, we have a partial scope structure. And this is where the project manages the operator and delivers selected corporate services. Now, what's critical here is that the model supports governance, in addition to effective decision making, and then a strong alignment between all the parties involved. And if you're interested in also learning more about this area, the company recently wrote an article that explores typical operating models across the sector that's also been linked in the slide below. But ultimately, the goal is to ensure that the project operates in a way that balances performance, cost, risk, while maintaining enough flexibility to adapt over time. And then this brings us to how the operator organization is typically structured on the next slide. So at the top level, you have management functions, and these are responsible for the overall governance, decision-making, and ensuring that the project operates in line with this strategy. So these are functions like a CEO, regulatory, HR, legal, and finance that are typically included within this layer. And then supporting that are operational teams who manage the day-to-day activities. So this is planning, coordination, and execution of maintenance and logistics. And then there's also technical specialists that provide expertise in areas such as engineering, asset integrity, and performance monitoring, ensuring that all technical issues are addressed effectively and proactively. And then in addition, the operator works closely with key contractors, such as the turbine suppliers and BOP agreements. And then we've also included some examples of site-based roles, which we'll touch upon on the next slide. And then moving to the next slide, yes. So we see here that this setup is highly project specific, but you will typically see roles such as a site manager, a shift supervisor, HSE manager, site assistant, warehouse coordinator, platform engineer, high voltage personnel, contract manager, and site planner. So the site manager or the head of operations is responsible for the overall coordination of activities on site. So this is ensuring alignment between offshore operations, onshore teams, and contractors. So we have listed out some example responsibilities and tasks for each of these functions, where each of these roles plays a key part in ensuring that daily operations are executed safely and effectively. So this is from planning and coordination of logistics and on-site supervision. But what's really important here is coordination. So these roles, they don't operate in isolation. So they really need to work seamlessly together with clear communication, well-defined responsibilities to ensure smooth and safe operations every day. And then moving to the next slide, I'll hand it over to Matti, who'll walk us through how OWN activities and the project lifecycle.
Perfect. Yeah, let's jump straight onto the next slide from here. Thank you. So just a quick recap. So far, you've heard about the technical overview of O&M, buildings, offshore logistics, spare parts, control centers, helicopters, etc., and how operational organizations set themselves up. The second piece, I think, especially matters a lot for the supply chain here, because it determines what the operators keep in-house and what they source. I'll get back to that in a minute. Now we get more into the actual activities and starting to the basics, which Annika has also mentioned somewhat in the beginning, but I would like to recap again that O&M is really two different things which are often mashed into one term, which is operations on the one side and maintenance on the other side. Maintenance really keeps the asset fit for purpose. So that means that the turbines are producing the expected output at a given wind speed. So that's all the planned activities, preventive maintenance, but also unplanned maintenance, and also major correctives, major component replacements, which can be either in a preventive or corrective manner. Then operations is really the monitoring and the controlling of the wind farms. So there you see all the SCADA error messages coming in. You do all the switching activities. You are responsible for marine coordination of all the vessels and helicopters, so quite a complex task as well. And operations and maintenance really enable each other. And underneath of both, there are your support functions, health and safety, asset integrity, data and performance analysis, etc. So these really build the foundation and the context within which O&M activities can be performed. On the next slide, I'll share a little more detail on what's done in the different project phases to support these activities. And the main point really on this slide is that O&M does not start at the start date of operations. It actually starts much, much earlier, and many decisions that shape how you will operate later on are taken in the development phase already. And I guess relevant for this audience is that the logistics setup is largely determined early on. So which harbor is close enough to the site? Do you have the right workforce? Are you restricted by tides or other things? Plus, of course, the onshore side. Do we have roads available? Can we transport our personnel? Do we have routes for sourcing spare parts, etc.? So all of that base work then flows into the operations preparations, where the concepts worked out get aligned with the design. So for instance, a helicopter access solution means a hoisting platforms on the turbines, maybe a refueling facility on the offshore substation, probably a hangar onshore. So all of that gets cemented into the operational contracts, the turbine service agreements, balance of plans agreements, etc. And only then comes actually the operation. And the message is that O&M is largely defined long before the project goes operational. And I thought this overview is helpful to the audience to explain this. Actually, we have a couple of examples on the next slide on what we do in this area. So both on the operations preparation side, so everything that happens before going in operation, and also what happens when we take over a site that we've prepared ourselves. So this is just for reference, but we can now move on to the supply chain side for O&M services. Yeah, so from here, I really want to illustrate what I think is most relevant for a supply chain audience around O&M services. And we'll look at lifecycle considerations, operator model considerations, and then I'll give you an overview of some of the selected operational phase scopes and contracts so that you understand how these things are typically managed and where supply chain can hook onto those projects and engage with them. So yeah, let's go into it. The slide is already up here. No, let's stay on the previous one. So this is what I would call an explanational procurement quilt for O&M services. So just a simple map of the key contract categories across the life cycle, hooking a bit onto what Annika explained earlier. On the left, you see 4 buckets: management services, wind turbine services, balance of plant, and other services. And the point really of this slide is to explain that different services get contracted across different phases across the life cycle. So asset and operations management is typically contracted on a 15-year term, sometimes with some optionality in this. And we see in principle 3 different archetypes in the market, which is in-house asset management with, for instance, a lead operator or developer. We see third-party contracts like Peak Wind would do, and we see thirdly dedicated project organization to take on operational responsibility. On the wind turbine services bucket, usually the first 5 years are executed by the OEM, driven by warranties and availability guarantees on the equipment. And then year 6 to 15, experienced operators would tend to pull scope in-house or contract this directly to third party, while non-utility style setups usually stay with the OEM a little bit longer. We have published another paper that explains a little bit more detail on that, which I've been linking on this slide bottom right for you. And then to the balance of plant, also there, typically the first 5 years are with a local supply chain setup, focusing on both preventive and corrective maintenance. Balance of plant is foundations, cabling, substations, and of course, in the first 5 years, also EPC and OEM warranties would play a role. Beyond the first 5 years, there is actually no fixed blueprint, I would say. This really depends on the local market saturation. Mostly, I would say it's third-party agreements or in-house with experienced operators. So this is what we really see. On the next slide, I would like to go a level deeper, looking at whether these scopes are typically done in-house or by third party or by the OEM. So building on the previous slide, here you can think of the double arrow at the top as something you can slide left or right, depending on the type of project. If it's a utility style project led by a large lead operator, the operator scope, what is shown in blue here, typically would extend further. So they'll often pull in some chunks of logistics, balance of plant, and wind turbine scopes, and only contract out specific specialist tasks or some tasks that require very local footprints. If it's a non-utility style project, the operator scope typically shrinks and is more pushed out into the third-party market. So this is really important to understand when you're thinking about engaging with O&M projects from a supply chain perspective, that depending on the project archetype, the decision maker, and the scope on offer can look very, very different. And yeah, on the next slide, I would give you a couple of examples of operational phase contracts which enable this. So even though we showed a simplified scope before, the reality is that in an operational wind farm, there is a need for a lot of agreements. It goes from waste management to security to road maintenance, all the way into the actual wind turbine and balance of plant service agreements. So the relevance for this audience is really, and we've picked just a few relevant ones here, is that every one of those contracts is an interface where you can formally engage with the project and offer your services. So that's where the supply chain really hooks in. What we've shown here on the slide is a selection, as I said, and I think a quite helpful reference is the paper we've been linking here, where we have mapped out more than 30 contracts that a typical wind farm has in place during operation. And even those are only the key ones, so there can be even more than that. So I thought it would be quite helpful for this audience to understand the full breadth of operations and maintenance, also from a contractual perspective, because it goes beyond, let's say, the obvious ones on the wind turbine and the balance of plant. All right, on the next slide, I will like to look at a little bit at O&M optimization and close out with some future outlook. What you're looking at here is realized OPEX. So these are real numbers across the operational years of offshore wind farms in Europe. The data comes from publicly available financial statements of offshore wind SPVs across Europe, which is around 60 projects, and Peakwind have assessed all of them. The key message is that offshore wind operations is really a story of continuous improvement. So you see some superstar projects that performed exceptionally well. They improved their economics substantially over the life cycle, and they also came out of the gate performing well because they prepared the operational phase thoroughly. On average, the European industry, offshore wind industry, is achieving around 3% efficiency gains over year on year on OPEX. So wind farms are, in fact, improving their cost base over lifetime. And the numbers confirm really that continuous improvement is a widely accepted methodology in the industry. The reasons for this picture, as you see it here, are manifold, I would say. This goes from day-to-day processes, which are simply getting faster. You do it the second and the third time, to predicting failures earlier with better condition monitoring, and obviously the supply chain around the wind farms here that support the operation are playing a crucial role in all of this. So looking ahead, especially here in the US, I think there is even more potential, and that's what I'll also want to cover, at least to some extent, on the next slide, which is also my sort of the closing point before handing back to Annika. So I would like to point at least my opinion, that O&M technology doesn't stop where it is today. I think across the value chain, we're seeing a lot of development that we expect will improve operational performance, also the cost base, and also safety over time. A few examples are here on this slide, reference to the suppliers, which, for instance, are drones. Already today, they can fly parts up to a turbine while technicians are working in the nacelle, which is reducing the need for an extra visit in case a part or a tool is forgotten, for instance. Then robots are climbing turbines already today as well. And I believe that with all the developments on humanoid robotics, we'll see a lot more support for operational practices going forward. A lot of movement is also in access systems. We see high-performing vessels. We see special cranes, up-tower cranes. We see other means, other access means that reduce the limitations that we have today when accessing offshore wind turbines. And then, of course, there is the big topic of today, which also in O&M is AI. And we do expect that AI will play an incredible role, actually, in offshore wind operations, from fault recognition, predictive maintenance, work process optimization, error code management, power curve optimization, and much, much more. So it will really make offshore wind O&M higher performant and safer, which would be our expectation going forward. So yeah, this is where we see the trends going and what the next wave of O&M technology might bring in this industry. I think a few of these are particularly interesting in a US context. And with that, I'd like to hand back to Annika.
And then moving to the next slide. Yeah, thanks everyone for listening today. I'll just do a quick recap of the presentation. So offshore wind O&M, it brings together operations, maintenance, logistics, support functions, all integrated across technical, commercial, and HSE activities. At the core, the objectives are safe operations, reliable energy, production, and long-term asset performance. And achieving that depends on strong coordination, clear roles, and effective governance across all parties involved. Logistics, they play a critical role, enabling offshore access through vessels, through helicopters, and the port infrastructure. And this directly influences cost and efficiency. And then it's also too important to remember that O&M spans the full project lifecycle. It's always project specific, so it's shaped by factors like site conditions, the distance offshore, and the chosen operator model. And then finally, value is created over time. So that's through experience, innovation, and continuous improvement. And with that, thank you. And we'd be happy to take any questions.
Thank you too for a terrific learning from the experts talk. Just so much detail and information for all the folks that are participating. So just want to give that quick thank you at the beginning of this. We had a lot of questions come in, and I've tried to order them in terms of relevance. So we'll get started with, what are the specific tasks in a day of a wind turbine, in the day of wind turbine maintenance? So what are they doing on the WTG on a daily basis?
Should I start and you just supplement?
Sure, you can start that one.
That's a very, very big question. I think maybe I take the perspective of an operational wind turbine site to share how a day starts there, because wind turbines, if things go right, they aren't visited too often. So, but if you're imagining to stand or to participate a day in an O&M site, which is responsible for an offshore wind farm, you would meet up in the morning, then you would review the current issues list. So do we have any wind turbines that are down, that are offline, or anything like that? You would look at any outstanding tasks from the previous days and weeks. And then you basically meet in a O&M daily meetup meeting to agree which tasks are on priority for the day. This can be on a vessel if it's an SOV site. This can be onshore if it's a CTV or a helicopter site. And then the sort of site manager, operational manager will decide which teams are going to which asset, depending on priority. Then there is a quite in-depth permit to work process that takes place where, for instance, if you wanted to go offshore where all your safety certification is checked, the helicopter picture that Annika shared earlier, this is essential training that you have to have if you want to be a technician to be transported on a helicopter. So it's not possible to do this without. So you go through all of these checks, permit to work systems, and then you're sent on either means of logistics to get you to the turbine, transfer over, and then climb it up or be carried up by an elevator and then do the task. So that is a little bit what's going on, I would say. Meanwhile, onshore, everyone is keeping track on everything that's happening offshore. Everyone offshore and onshore can call a stop work. So if anyone thinks that the wave heights are too high, the fog is too dense, whatever it might be, I'm not feeling well, I cannot be your buddy today, anything like that, will call a stop work, and then people return to shore. That's something that happens. And then the operations control and marine control center will make sure that they keep track on where you are at checkpoints. And then you're returning in the evening and you do a quick debrief on what happened. And then you start over the next day. It's a very intense work offshore. You work at 12 hours a day. You try to maximize the time on the turbine.
That's great. So how do they decide what mode of transportation is best suited? Helicopters, CTVs, or SOVs? And how do those costs compare?
So there are two answers to this now. So any given project has a logistics concept. There it's decided if you have a helicopter or you don't have a helicopter, if you have CTVs or SOVs. So this was what Annika showed you before. And based on logistics modeling, Met-Ocean modeling, you're determining what the most cost optimal and safely operatable setup is for a certain site. So that's more what's already determined in the development phase. So you do a lot of studies there to determine what you can do. How close are you to shore, for instance? How are the sea states there in the US East Coast? You have quite some seasonality, right? So how do you cope with that? So you set that up, and then for any given wind farm, you then have a spread of available means of transport available at a given day. And so if, let's say, the weather is calm and the distance isn't too far, then you would probably opt for a CTV, like the lowest cost and lowest complexity sort of way to get to the turbine. But if a wind turbine is already down and you have high sea states, which in many cases means high winds as well, you're losing a lot of production. So then it might be worth considering taking a helicopter, which is significantly higher in cost than a vessel, than a crew transfer vessel. But also it doesn't have the wave height restrictions, so it delivers an upside there. This is carefully assessed against each other in the development phase. Yeah, so I think on a given day you take the cheapest and easiest available, but it depends what you have indeed available. The cost was also a question. CTVs, crew transfer vessels, are usually the most lowest cost items that you can use, or means of transport you can use. Helicopters are more expensive. They have a base fee and they have a usage fee. And service operating vessels, SOVs, are also quite expensive in the context. But I think it's always, when we are doing these assessments, it's always necessary to look at the cost and the performance at the same time. So it might be more expensive from the outset, but the performance gain might well outweigh this cost adder.
And it's also right, Matti, looking at like the layout of the wind farm, working with like the turbine OEMs and BOP suppliers, in coordination with them when selecting the optimal setup.
That's great. So on a typical offshore wind project, how many vessels are generally out within the wind farm on a daily basis providing O&M services?
Really, it depends a lot. Let's say a modern wind farm would maybe have around 600 to 1200 megawatts, let's say a gigawatt wind farm. If this is an SOV site where the operation is managed largely from an SOV, it might be that only the SOV plus one daughter craft is active, if at all. These different factors, right? Like the reliability of the asset, service requirements of the asset, available weather windows, are all playing a huge role in how much logistics you need on a site. So you can have a very reliable turbine, but if you have a CTV setup and you can only access, let's say, during 2 months in the year, then during these 2 months you will have quite many vessels offshore because the rest of the year you don't. So that's a little bit the factors you need to outweigh. So I don't think there is like sort of a binary answer to this.
So another question that came in is, if a turbine is offline and being worked on, what happens to the rest of the offshore wind farm? Does it continue operating, or?
So for most of the cases, it depends on why it's offline. If there is, for instance, only a connectivity issue, fiber broke or whatever, the rest of the wind farm is probably just running as it has done before. If it is out because of a cable termination issue or something like that, it might be that an entire string, or in a very bad case, also the entire wind farm is having a problem. So it depends what the root cause of the issue is.
Some good questions we're getting here.
Yes. So here's a question for you guys specifically. It sounds like, how effective are global operators at integrating early stage supplier research, spare parts strategy, and local content requirements into these new projects?
Operators.
Maybe I can start on the local content requirements. I think because this is something we see across the globe. Usually when offshore wind projects are auctioned, independent almost, I would say, of, or at least in many markets, we see local content requirements in auction criteria. So if big global operators are bidding into projects, they that often comes with a requirement for local content. This means that a certain number of workforce, supply chain value, just the OPEX spend, vessels are sourced locally from a local market, and they commit to this within the auctioning, or within the bidding into an auction. So I would say some of them have to be effective in this, because they are just legally enforced by the auction criteria to ensure that enough local content is met. And I think we see this concept also working. I mean, many countries intend to build up an offshore wind supply chain. Some of them have a heritage from oil and gas as well. Look at, for instance, Scotland, which have a great base of services that can be deployed in offshore wind, but maybe those companies have been active mostly in oil and gas before, and they wanna expand into offshore wind as well. If then sort of the auction criteria is engaging this, then I think this is a good match that we have been seeing working in many regions. I'm not so sure I fully understood the points around supplier research and spare parts.
I think you nailed it, Matti. So we have a question about like the typical annual maintenance for a single generator. So how often are bolts tightened? Other preventative maintenance issues like that, re-greasing, things of those nature.
Do you want, or should I, Annika?
You can take that, Matti. I don't have the exact answer off the top of my head, but I think we're also happy to,
No, I think the question is, are you talking about a turbine which is already in the water since 20 years, which is like the first wind farms, or you talk about something new now today? Wind turbine O&M has been on a development journey also over the past years, and many things have been improved and changed, etc. Not everything to the better, I think. So some things also glitched here and there, but I think usually on a modern turbine platform and a good logistics setup, you're talking maybe about 24 to 48 hours a year that you are busy with preventive maintenance. So that means you're sending a team of X technicians. It depends on the platform and how much space you have, etc. And then you're conducting all of these preventive maintenance tasks within a relatively short duration of time. You can even optimize that eventually. And OEMs are working on even optimizing that further. So that's the preventive part. Then you have certain years where you have overhaul requirements. So there you do an oil exchange, for instance. You don't only do the greasing of some parts, but you do really a full oil exchange. You do maybe preventative exchanges of some components. So these are overhaul years. It can be quite a significant duration that is then required, and also added cost. That's on the preventive side. On the corrective side, this is really turbine platform specific and also site specific. We are seeing a few visits per turbine per year, I think, speaking generally about the industry. So this could be 2 to 3 visits in a very good year. It could be up to 10 visits in a very bad year. So I think somewhere in this envelope, you might be when you look at minor correctives. So these are correctives that can be handled without special logistics, I would say, without jackup vessels, etc. Major correctives, we've actually been doing quite a lot of work in peak wind to assess major corrective failure rates through our subsidiary Sea Impact. So we are tracking jackup vessels, and we're seeing when they are in offshore wind farms. So we have an idea about sort of the industry failure rate or the industry major component replacement rate. And I would say, depending on the platform, right, maybe between 3 and 7% or something like that. It depends also on the year of operation, etc. I see I'm up on time. Whoever mentioned this question, I'm super happy to talk a lot about this. I did a lot of research on this.
Well, this is great. And with that, I'll take you to out of the hot seat and just thank you once again for a great presentation, you know, and willingness to connect further, I'm sure, you know, with stakeholders in the offshore wind market as these projects continue to move into the operations phases and deliver power to various states along the East Coast. So just want to thank everyone
you for
else
having us.
Yeah, no, it's been terrific. Just want to thank everyone else for joining us for this learning from the experts webinar today. A reminder that the webinar recording and presentation slides will be available on NYSERDA's website. Our next webinar in the series will be on July 15th. Sarah Fortuna from AIS Inc. will discuss the work of protected species observers in infrastructure development in the marine environment, including offshore wind development. You can register for future webinars through our events page at wind.ny.gov. We also encourage you to check out past webinars in the series on NYSERDA's YouTube channel. If you'd like to request a topic or speaker for this series, please email us at offshorewind@nyserda.ny.gov or fill out our Learning from the Experts survey posted on the events page. Thanks again for joining us again today, everyone. Bye.